Assalamu alaikum students. Article for today is torque. Torque, you have already read it in class ninth, that torque is basically the turning effect of force, or you can simply say the moment of force. This torque is basically responsible for producing a rotation in a particular body, right? So talking about its formula, the formula for torque we generally use is tau equals to r cross f, and all of these are, obviously this is a vector product, so we are putting an arrowhead over them. So tau equals to r cross f, and if I open this cross product, I get r f sine theta, right? And this tau equals to rf sine theta. Talking about its unit, the unit of torque is obviously equal to, if it is r and f, calculating the value, obviously for the maximum torque it would be equal to meter for r, and for f it is newton. So as a standard or as a convenience, we write it as newton meter, right? um, Now, what about the direction of torque? Direction of torque is obviously calculated through right hand rule. And how we can calculate it? Suppose this is the direction of r and this is the direction of f, and we are asked to calculate to get the direction of torque. So we will draw vectors starting from like the curl of the fingers in the direction of, from starting from r to f, and the thumb will indicate the direction of the torque, which is perpendicular to the plane in which r and f are placed. So this is the direction of torque, or you can say the direction of the normal, which is indicating the direction of torque. So that's how we can calculate the direction of torque. Next thing is what are the dimensions of torque? So the dimensions of torque can be easily calculated by using its formula. We know that Newton, the dimensions for Newton, that Newton is used for the force. So we are having m l t minus 2, right? Because it is, force is equal to ma, then m, we are having this m dimension, and for acceleration we are having lt minus 2. And along with that we are having this m, that is a meter, that is of length, so that's how we can write an l over here. So the dimension for torque is ml square t minus 2, right? Now, the new thing for you is how torque is acting on the rigid body. It's not something new. You have already read in class 9, but this is a more a descriptive way to explain you. In this condition, you can see that we are having a spanner, and this spanner is basically opening a nut, right? This is going to be, okay, this is going to be the pivot point. This is the pivot point about which the whole spanner is rotating, right? And this is the point of application of force. At this point, force has been exerted in this particular direction, right? This is the direction of force provided. And we can see that the distance between the pivot point to the point of application of force, this distance is basically known as the moment arm, which is represented as r. Now we see that if this is r, I can extend this r like this. So angle between r and f is equal to angle theta, right? So now we see that this force is not perpendicular, not parallel. Like if it was a parallel case, so in this case direction of f and direction of r would be the same, and the formula theta would be equal to 0 degree, and sine 0 degree gives you the value equals to 0, and in this regard torque would be equal to 0. So no force can be produced when f and r are parallel, right? What will happen if this is the moment arm, and the force applied is in this direction. They are having an angle of 90 degree with each other. When they are having an angle of 90 degree, so theta would be equal to 90 degree, sine 90 degree would be equal to 1, so torque would be maximum in this case. We are discussing a case when force and r, they are making an angle of theta, right? So in this regard, what we have to do, we will definitely divide this f into its components. If I divide f into its components, like, it would be definitely the y component would be f sine theta, and the x component would be f cos theta, right? This is f cos theta and this is fy sine theta. Now you see that which component of force is perpendicular to r. So we see that f sine theta is the component which is perpendicular to r. So I can write tau equals to r into f sine theta. So that's how it will become r cross f, right? And also talking about the direction of torque, it would be calculated by simply using the right hand rule, right? Now in the second case, what would happen if I draw if I resolve this r unit r, that is the moment arm, into its components, and see that which component is perpendicular to f. So for that, what I have done, I have drawn the components of r. Okay, so you see that this is the projection that I have drawn on the, this is the line of action of force, and I have drawn perpendicular on this line. So this is the y component, so I can write ry over here, and I can write rx over here, right? This is rx and this is y. Now I see that rx component, like, this is the rx component, it is in direction to the force f. And this ry component, if I draw this y component like this, I am drawing a parallel vector over here, I see that the angle between ry and f is equal to 90 degree. So this shows that ry component is basically responsible for producing torque in this circumstance. So torque is, in this condition, would be equal to f into r sine theta, right? And in that condition, I can write again rf sine theta. Since this is the we are writing the magnitude, so the arrangement of the vectors is not important. But when we talk about the direction, so direction changes if you are changing the arrangement. For r cross f, we are having direction, like, suppose if it is n unit vector, then in case of having f cross r, the direction of f cross r would be minus n, right? So that's how we can choose this condition. But generally we are taking r cross f, so that by choosing the angle to be in the anti-clockwise direction, that is from r to f. So that's how our n unit vector, it always comes in the positive direction, and r cross f is preferred, right? Now coming towards the fact that how couple is going to produce. Now we see that if in this example, in this figure, you can see that there is a steering, and when we apply the force on the steering with our hands, it would definitely in the upward direction from this side, and from this side we are going to uh, push or pull it in the downside direction. That's how couple would be generated. Since the torque in this direction is upward, or in this direction it is acting in the downward direction, both forces are having equal magnitude. they are in anti-parallel direction, and they are also acting at different points of the same body, right? So at this particular point and at this particular point, A and B, these are two different points. And obviously they are acting on the same body but at two different points, having magnitude equal to each other and the direction anti-parallel to each other. So that's why they generate couple. And the torque in this case would be equal to, um, this would be the couple arm, right? Couple arm into the force, right? So the value of force for both of them, it is basically F. And the couple arm, the value of couple arm can be calculated as Ra plus Rb into F, right? So Ra plus Rb would be equal to R. So ultimately the equation would remain the same. So tau equals to Rf. And how can we calculate, how can we find out the direction of torque in this situation? By simply using the right hand rule. Just curl your fingers in the direction of like from F to the other F, from first F to the other F. Then in this condition we see that so you see that the direction of R has been given in this direction, right? And if I am going to curl my fingers starting from R in the direction of F, like the direction would definitely be like this. So in this condition, if I curl my finger along this direction, then my thumb will indicate the direction of the torque, which is definitely going to be now in the upward direction as shown in this figure. So that's how couple generates in the body, and the body start rotating. Okay, this figure 2.29, it explains that what is going to happen if I am going to resolve this F into its components. This would be the Fx, that is F sine theta, F cos theta component, and this is F sine theta component. And I have to choose that component which is perpendicular to R. So F sine theta into R. In the second condition, if I draw a perpendicular of R on F, yeah, like this. So in that condition, this would be the sine component, and this would be the x component. Obviously, which component is perpendicular to F? So this component is perpendicular to F. So I'm going to choose this to calculate the value of torque. So that's how our article for today, that is torque, has been completed. Thank you so much. Allah.